SSD Global Summit. My name is Ayong Shin and I will be your MC for today's event. Today's summit, hosted by Samsung Electronics Memory Business, is a meaningful gathering of the most influential media leaders and bloggers from all around the world. Today is a place where the infinite potential of Samsung SSD business in the new era will be showcased. We have prepared various programs to demonstrate Samsung's outstanding technologies and leadership. We also have great performances prepared, so please stay with us until the very end of the event. With that said, we will begin with a welcome speech by Mr. Eun-Soo Kim, Senior Vice President of Brand Product Marketing Team. Let's welcome him to the stage with a great round of applause.
Good afternoon. Good afternoon, everyone. Thank you for joining us today, and I welcome you to Seoul at the Silla Hotel. Originally, we planned this year's SS Summit in July, but we had to postpone it. You can guess why. You can guess what happened this summer in Korea. MERS, or Middle East Respiratory Syndrome. It is really hard for me to pronounce it, but anyway, MERS has disappeared now. And as you can see there, the sky is clear and air is fresh enough to invite you all to Korea. Please enjoy the fresh Korean autumn during your stay. This year marks the 4th anniversary of the Samsung SSD Global Summit. 4 years ago, back in 2012, we launched the first Samsung SSD Global Summit under the theme of unrivaled performance, featuring the legendary 840 Pro and 840. At that time, the global SSD market was still in its infancy, and we tried to thrill the market with the best performance to really maximize user experiences in their computing lives. Every year since then, I think we have strived to introduce new technologies that would provide consumers with incremental value. In 2013, we announced the first 1 terabyte consumer SSD with the name of 840 EVO, signaling to the market that capacity really matters. Last year was a historic moment for us, launching the world first V-NAND SSD 850 Pro and 850 EVO. All these innovations were industry milestones and addressed the vision not only to give consumers a vastly superior experiences of hard disk drives, but also to offer great capacities at affordable prices. This year we find ourselves at another turning point, and we believe we are marching into the next year. Not only has the market grown so rapidly, but consumer needs have also evolved. I won't tell the detailed numbers, but according to the recent Google consumer survey, consumer awareness on SSD is increasing, and more people are looking for SSDs with, number 1, better capacities, number 2, better performance, and then better value. It is our belief, it is our conviction that consumers stand at our center of everything we do. And it is our goal to satisfy our consumers with our ability to offer greater capacities and higher performances. while ensuring that consumers always receive the best value. As we have done always, our journey will continue to thrill the market with top-tier capacity, top-tier performance, and top-tier endurance SSDs. Again, thank you very much for joining us today, and I hope you have a wonderful day in Korea, and please enjoy the show. Thank you very much.
For your welcome speech. Now, let's begin the 2015 Samsung SSD Global Summit. The summit will provide diverse programs through which the outstanding technologies and leadership of Samsung will be presented. After the coffee break, a Q&A session will be waiting for you, so please stay with us until the very end of the event. We shall now start Samsung Partner Session with a speaker from overseas. Mr. Peter Marone, a Senior Vice President of Engineering Department at Chiron Higo, located in the United States, will give a presentation called High-End Computing with SSD. Please give him a big round of applause.
Chiron Higo is a manufacturer of equipment for television broadcast and sports analytics. And we've been in the business for a lot of years, since the 1960s. And we've seen the evolution of storage media over that time. And it's actually very exciting to see how something like SSD technology has kind of changed our business in a very, very significant way. And I want to talk about that today. I want to give you a little bit of information about who we are and what we do, and share some of the experiences, first-hand experiences about how SSD has really improved our lives. Chiron Higo actually started in the 1960s. Chiron Corporation was a New York-based corporation that started making arrival and departure boards in LaGuardia Airport in New York. Those big tube televisions that you used to see in the airports, and they had a way to type characters and have it electronically come on the television, those tubes. And one of the executives from a major broadcaster was going through LaGuardia Airport, saw that technology and said, hey, we could use that on television. We could use that to generate graphics and character and text on television. And really, we've been doing that since the 1960s. We've been doing it so long that in the English language, the term Chiron is actually a noun formed after our company name, and basically it means an electronically generated caption or graphic on live video. And everything we do is about live video, live to air, real-time video. So right around the same time in the 60s, another corporation, Higo Corporation in Sweden, started doing sports analytics, sports timing technologies, and moved on to sports graphics, even using Chiron equipment. And about two and a half years ago, Chiron and Higo merged, and here we are today, Chiron Higo Corporation. So we really service two significant market technology segments. As I mentioned, broadcast graphics, which is news, sports, entertainment, and sports technology, sports analytics technology, player tracking and things like that. We're a global company. We've got offices in New York, as I mentioned, in Sweden, the Czech Republic, Finland, Norway, Germany, Mexico, Amsterdam, and even here in this region in Singapore. Here's a couple of the partners that we service, and you'll probably be familiar with some of these. We had a slogan in our company that went, "The company the whole world watches." And I'm going to show you a video clip of some of the product that we produce, and you'll see why we use that slogan. Take a look at this clip. technology. We do a lot of graphics for stadiums on their big boards, kind of like this monitor here. News, touchscreens, illustration. Live-to-air sports illustrations. Done a lot of work recently with Major League Baseball. Traditional graphic leaderboards, stat boards. These are all called chyrons. I think most everyone has kind of grown up with our technology and not even realized it. As I said, we've been a technology company for 50 years, and in that time we've used all sorts of storage media. We started off with 8-inch floppy disks, if anybody's old enough to remember those things. Winchester drives, Bernoulli drives, and all the way to this day to SSD technologies. And you know, SSDs have made such a significant impact on our business. You may not even realize things like time to market, time to manufacture, time to get equipment out the door. And most importantly, the SSDs have made a very significant impact in the user experience of our products. One of the things that, kind of sets us apart from, you see a lot of graphics like that, and graphics can be generated in lots of different ways. Everything we do is what we call real-time graphics, or live-to-air graphics. They're not rendered, they're not pre-rendered. It's done live. And like, for instance, in a clip like this, you saw this earlier, you'll see, ball trails, you'll see players running on the field, and the color designates how fast they're running. Graphics that follow the player, and then traditional, graphics with statistics. Traditionally, you'd see a graphic like this maybe, at halftime or in between innings. They would be generated in a post-production process where they take the video, go through frame by frame, kind of manually paint graphics and figure out the timing and things like that. And you might even see it the next day in a highlight reel. But these graphics here were done real time. They're done live to air. Okay? And in order to do something like that, it takes, well, let's talk about video for a second. So what is real-time video? So, video, we know video is effectively a series of still images played one after another. And in high definition, each one of those frames is about 6 megabytes of data that have to be processed. And there's, in the US standards, there's 30 frames a second, okay? Which, is approximately 200 megabytes of data a second that has to be processed. And most importantly, each frame is about 30 milliseconds. So every 30 milliseconds we get a high definition frame, we've got to process data, draw graphics, and get it back out of our systems. That's real-time video. And really, to do a clip like you saw, that baseball clip, it takes 2 pieces of information, or 2 processes. One is getting the actual player data, the positional data on the players, where they are so we know where to draw the graphics. Because we can't have a human, doing that sort of stuff in 30 milliseconds. It's just not possible. So we need technology to actually determine where the players are. And then on top of that, then we need to be able to take that data and do the graphics processing tied to that data stream. The output of that is that cool sports video that we saw. So let's talk about how we get the data, how we get the player data. So we have a system called TrackHab, and this was developed in our Swedish organization. And it uses stereoscopic real-time image analysis to generate XYZ coordinate position on every player on the field. And it does this 25 times a second. So 25 times each second, we get a stream of data for every player in the position that they're in. And it's done with 2 camera arrays, a couple of meters apart. The data from those camera arrays is sent down to a processing computer where we do real-time analysis on it. Here's an image of what some of those cameras look like. We manufacture these. Each camera array that you see there has 3 high-def cameras. They're spread out so that between the 3 cameras they look across the whole field. And there's 2 of those camera heads for the stereoscopic imagery. So it's about 6 gigabytes a second that comes down over fiber. Our computer systems process that data and again generate the XYZ coordinates 200 milliseconds delayed. So it takes about 200 milliseconds from when the light hits the CCD sensor to when our computer systems output this player is at this position XYZ. This player is at this position XYZ. It does that 25 times a second. And that data is used to do graphics live, and it's also used for player analytics, efficiency, velocity, maximum acceleration, turnaround time, things like that that we can then put as information to help tell the story. So that's kind of how we get the data. And then how do we take that data and put it on the live video? So the video we don't use the video from the cameras that we have, we use broadcast camera video. So we take video from a cameraman on the field. Obviously the goal is to make that cool video happen on a monitor. And we're in the middle of that process. So we take 30 milliseconds, a frame of video from the broadcast production camera, take the data from our data processing systems, paint the graphics on the video, and get the video out the door. Now a lot of the graphics that we do come off of media. Movie files, animations, graphics. So we need to be able to retrieve data off media, and then we also record the video back onto the media. So media is a very important part of the real-time processing, and SSDs are ideally suited for this because that's right in the pipeline of our video processing, that media. So if that media slows down or doesn't deliver the data when we need it, it's going to affect that 30 millisecond time, and if we take longer than 30 milliseconds, the frames look jagged, stuttery, or they drop out, and that's really bad. People yell at us when that happens. So SSDs are really, really important. We rely on reliable, fast media. So, as I said, we've been a hardware company for many, many years. The things that we do used to be done with discrete semiconductors. Now we're using PC computers. They're all Windows-based. We're really a software shop now. Very much like the gaming industry, which also does live video processing. We use CUDA for our data analysis. We use OpenGL for graphics. We're very reliant on CPUs, core count, and clock speed. And as I mentioned, we're very, very reliant on media. We've been involved with media for a very long time. We have a lot of very different environments in which our systems operate. And as a result, we've kind of carefully built our own systems, select our own processors and components. One of the environments that we actually operate in is a hosted service. So we have a hosted service called Access World Graphics, which is really used by about 5,000 news producers every day to generate animations and still graphics and for collaboration between organizations. So this animating map that you saw there is generated by a render farm of graphics rendering systems, heavily reliant on data retrieval because of the tremendous amount of data in doing animated maps like that between aerial photography and street level data, traffic data, and things like that. So that's one of the environments we live in a kind of a traditional hosted service data center. Another area that we live in is we have a product called Paint, and Paint is what we call a telestration product, and it allows an operator to literally paint live graphics on a video feed with their finger, on a touch screen, or with a stylus. And we have an application where we're using Paint on a helicopter. So helicopters require 12-volt power, they require very small form factors, so computer systems need to live in that environment, and more importantly, they need to be very, very rugged and robust because of the vibrations. So something like this has to be vibration tested on a table. All the major components are glued down. Even the PCIe board is literally glued into its slot. So, you know, robust, reliable components are important in an application like that. Our core products, our core graphics rendering machines are kind of standard rack mount, high performance, high reliability computer systems. And these will live on a sports truck, drives around the country. It'll live in a rack room for a news organization, or maybe flown around the world in a like a flight case. So again, just reliability, robustness, very important. Even we have freelancers that travel the country, and they'll even carry their equipment with them: backpacks, flight cases, carry-on luggage. So, and you know, we need to support our products. The life cycle of our products is about 5 years, sometimes more. So the quality of the components that we use are important. The longevity of those components are important. Now, our market needs are changing just like every other market segment. And they're very different. You know, our news organizations and our sports clients they have very different needs. In news, there's a lot of consolidation going on. They're very, very cost conscious. There's a lot of price pressures, and really trying to do more things with less people. Sports is very different. There's plenty of money in sports. Their whole interest is, how do I make the user experience better? How do I keep the eyeballs glued to this event and not channel surf or look at their iPads or whatever? So they're really focused on how to make more compelling graphics, how to tell the story, how to help the producer educate the viewer on the statistics that we're looking at, on the strategy of the coaches, how to kind of enlighten the viewer, explain the game. And then of course, you know, the sports industry is leading in the 4K content creation. And 4K and ultimately 8K is really going to push the limits of our technologies, storage media, processing, etc. So, enough about Kyra Hago and what we do. We're here to talk about SSDs and how they've impacted our business. And they really have. They've impacted us very significantly. So the first thing I want to talk about is how SSD technology has helped reduce our time to market. So if you remember this wonderful diagram here, this is showing our video pipeline and how the media, storage media, is really integral to that pipeline. Well, before SSD technology, we were obviously using spinning disks for this. And I'm a software engineer, and I can speak from personal experience. I spent many, many, many man-months coding around the physical limitations of spinning media, worrying about rotational velocity, whether sectors are on the inner parts of the media or the outer parts of the media, whether, you know, if I'm doing read and write simultaneously, how is that going to affect performance? Fragmentation. And even if we're dealing with RAIDs, we always have to consider, well, if a RAID is degraded, it's going to have reduced performance, and we've got to compensate for that. So we literally had to write a lot of code, because in addition to the media being kind of in that video pipeline, there was also this asset management component going on, where human beings were pushing content to the media, taking content off the media. While a show was on the air, they would be preparing for the next show. So randomly, more files were being pushed on the media, affecting performance. So we had to think about all this, and it hurts my brain even now thinking about it. But we wrote lots and lots of code to manage the media, throttle the file transfers, ensure that we don't affect the video pipeline. And since we've switched to SSD technology, literally that amount of time has gone to zero. So we have not had to worry about media performance in the majority of our products anymore. So we haven't had to compensate for humans pushing files. We haven't had to do any of that work. So that time that we used to spend coding around spinning media, the physical constraints of spinning media, is gone. It's gone to zero. And that either gets us to market faster or allows us to actually write code to improve our products and build our core competencies, not worry about the media. So this has been a very significant advantage to us. Another way that SSDs have helped, as I mentioned, we manufacture our systems. We build about a little over 1,000 systems a year. And our systems are very custom built to our clients' needs. It's not the kind of thing where we can kind of configure them, put them on the shelf, and get them ready to ship. So we kind of, ship to spec. And, like a lot of businesses, we get orders, probably 70% of our orders in the last, couple of weeks before the end of a quarter. So getting systems out the door becomes very important toward the end of that, that quarter. And, with systems with a lot of storage, those drives have to be, the OSs have to be imaged, the RAIDs have to be built, and that takes a lot of time, especially initializing large RAIDs of spinning media. So it could take many, many hours just to prepare a system to ship, let alone burn-in and test and everything else. SSDs have completely eliminated that bottleneck. So the time to image a RAID of SSDs is an order of magnitude less. Initialized drives is almost trivial. It's really kind of eliminated that entire piece of our manufacturing process, and really helped us to be able to be much more agile and more responsive. A lot of people don't realize that aspect of manufacturing with SSDs in a systemic perspective, but it's really quite good. Probably the most important benefit of SSDs for us has been how it's helped our users. So in a traditional, kind of a typical sports environment, you'll have producers yelling to operators that operate our equipment, hey, I need a graphic with this guy's headshot and this caption. The graphics are all built live. So an operator literally loads a template, which could take a couple of seconds, finds the graphic, types in the information, checks it, previews it, and sends it to air. And meanwhile, while he's doing that, the producer's yelling at him, get that copyright on the air, get that copyright on the air. So, very stressful environment. The first systems that we shipped with SSDs were shipped to one of the Olympics. And when the operators came back, they said, oh my goodness, those systems could handle anything we threw at them. And they said, for the first time, we were able to keep up with the demands of the producer. So there's a real-world example of how something as simple as an SSD drive really impacted our users. And even to the point where when we started shipping all of our, we started offering SSD drives, we offered them as options at a for cost, because they were a lot more pricey back then. And immediately, no one ordered systems without the SSDs. And they even ordered upgrades to systems that they already had to put SSDs in there as well. So we actually, had a bit of a problem sourcing the drives initially. That's where Samsung came in. They really kind of came to us and said, okay, we can make sure you'll have your supply you need. And we've been using Samsung drives ever since. It's been a great partnership. But really, the impact on users has been phenomenal. Even something as simple as, hey, they have to reboot a system right before a show. Just the time to boot is significant. Another area where SSDs are really vital in our business is with 4K and ultimately with 8K. We talked about the paint system, and we make a 4K version of that paint system, that telestration system. And when we deal with 4K, we have to deal with it virtually uncompressed. And we need to do record and playback simultaneously, which is about a gigabyte per second read and write simultaneous performance. Realistically, it would be very difficult to do that with spinning media and make a system that's robust and reliable and useful for our clients. SSDs have made this product a reality, and it's really going to empower manufacturers like us to meet the needs of the broadcasters in 4K and beyond. So, some of the things that we're looking forward to going forward. cost reduction. I mean, as I mentioned earlier, especially in our news market segments, there's a significant price sensitivity. We love the way that the cost per gigabyte of SSD technology is going down, and hope that continues. Larger capacity, especially with 4K and 8K, media files are only getting bigger, and we need to store them and store a lot of them. So we're very excited to see the new 2 terabyte drives, the 850 Pro 2 terabyte drives. That's going to be a real useful tool for us. Higher endurance, reliability is important. We do tend to over-provision our drives, probably more than most. I think we do 20 to 25% over-provisioning on our drives. We want them to have longevity and better performance. Now, capacity certainly helps that, but we'd love to see some kind of more inherent endurance improvements over time, and speed. The NVMe, the promise of NVMe is very, very enticing. Really just being able to eliminate the bottleneck of existing electrical interfaces is going to be very, very exciting for us. Fundamentally, from a manufacturer's perspective, SSDs have really, really helped us. It's been very, very amazing to see how one component can evolve in a way and have that much of an impact on our business. Samsung has led the way in that and have been a great partner for us. So thank you, and thank you for allowing me to share this with you.
Thank you, Mr. Marone. Your presentation about how Samsung SSD with high-end computer processing capabilities is making real-time analysis in diverse sectors was truly insightful. Ladies and gentlemen, please give Mr. Marone another round of applause. Our next presentation will be given by Mr. Do Young-jung from the Brand Product and Sales Group at Samsung Electronics. His presentation is titled Samsung SSD Solution. This will be followed by Mr. Chung Chi-seo's presentation from the Market and Communication Group to discuss SSD market creation. After Mr. Seo's presentation, Mr. Jung will come up again to showcase our new product. Let's welcome Mr. Jung with a great round of applause.
Good afternoon, and welcome again to the 2015 Samsung SSD Global Summit. Right? We really appreciate everybody here taking their time to come all the way here to listen to what we have to say. So, thank you. I think most of you would have noticed that our slogan for this year is marching into the next era, and hopefully this next presentation is going to elaborate on what we mean by this. So, let's begin. At Samsung, we like numbers. We love big numbers. So let's start off with one. 84 billion gigabytes, right? This is what we are estimating that the total demand for NAND flash memory will be for 2015. Let's put that into a little bit more perspective, right? We divide that by a 250 gigabyte drive. That's going to give us approximately 336 million units. Right? So that's more than enough to go around for everybody in the United States. Now, that certainly feels like a significant amount, right? But I think we can all be assured that we are only now just witnessing the tip of the iceberg. Because before the end of this decade, we are projecting the demand to more than double to 209 billion gigabytes. If we consider the figure to be just 28 billion about 3 years ago, I think we can all appreciate the pace of this industry moving forward. if we look at the primary applications that's driving this tremendous growth, you'll see that it is mobile phones and solid-state drives, right? But within a couple of years, in 2017, we are projecting that SSDs will be the #1 leading application in NAND consumption. So, at this point, we ask ourselves a question, what's driving, what's fueling this tremendous growth in the industry, right? We have to start by looking at a few, but simple examples, right? Simple, tangible facts about how the market dynamics has been shifting. Let's take a look at the first one. Performance. From the past era of mechanical drives, SSDs have now come to maximize the current potential of the SATA 3 interface, right? This is sequential read speeds for our 850 Pro, 550 megabytes. And as data continues to accumulate and to grow and to expand in size, the value of SSDs has that much become more recognized and more appreciated. Affordability, cost. As our NAND technology continues to innovate, so does the efficiency in manufacturing, right? As a result, SSD's costs for consumers have improved significantly over the past 5 years. Back in 2010, a retail SSD of 1 gigabyte would approximately be a little bit over $3. According to our latest market data, in July, that has dropped below 40 cents. But what does that imply, right? 40 cents. I think that's really significant because what this means is that now an ordinary consumer will be able to afford a 500 gigabyte drive below the $200 mark, right? And although that currently we see the average gigabyte one drive in the retail market to be a little bit over 300 gigabytes, we're seeing this pace pick up faster than ever. What we are also seeing internally is the adoption rate picking up, right? So, pre-installed SSDs on laptops are now 29%. So, 1 in every almost 3 laptops will now come pre-installed with an SSD. And we feel this growing adoption rate can also be closely linked to the rise in SSD perception and also its awareness. There's just more choice, right? The choice of SSDs has expanded tremendously over the last few years, right? This is natural, right? As our consumer segment continues to grow, so does the product suited for their needs. Also undoubtedly moving away from the current 2.5-inch form factors, right? And we're seeing more and more of M-SATAs, M.2, half-and-half length, and so on. And you'll notice that starting this year, we've also started to target SSDs to become the core solution to external portable storage devices. So, we briefly took a look at how the growth of this industry is expanding and also some of the reasons that's fueling this growth. But these are just tangible figures, right? It was ignited by technology, innovation, and some important intangible efforts of trying to change the general perception and also educate the consumers. So to illustrate this, and to show some of our humble role in this effort, I would like now to invite onto the stage Dr. J.C. Seoul, who is the Director of the Memory Division's Marketing Communications Group. So please help me to welcome Dr. J.C. Seoul.
Good afternoon, ladies and gentlemen. I am J.C. Seoul, Group Leader for Samsung Memory Marketing Communications. I've been organizing this event for 4 years, but this is my first time actually to appear in front of all of you guys. And today, I have a big honor to present our market creation story to you. Let me start with data from Google Trend. As you can see from this one, the two lines indicate search for SSD and HDD. In 2012, the search for SSD actually surpassed that of HDD globally. And for some countries, this happened as early as 2011, when we first entered consumer SSD market. Worth noting here is that 2012 just coincides with the year we made a big contribution to SSD market growth. Late that year, actually, we climbed to #1 in market share. Now, as you can see, in 2015, the gap between SSD and HDD is huge. So from this trend data, we could tell, so big trend is already toward SSD. Then, how many people know about SSD now? As of August this year, about 38% of general public know about SSDs. This is based on the study we did with Google toward 1,000 US online users. If we narrow the target audience to Power PC users, like yourselves, the awareness level will be much higher. As we could easily tell, everyone here knows about SSD, right? So as an SSD marketer, this number 38% is actually gives me big motivation to work. I have to work a lot harder at our side, at my side, because everyone deserves much better computing experiences from SSD, enabled by SSDs. Another point I'd like to address is, you as members of media and press are just as powerful and influential as Google. You guys are second biggest influence in people's information search for SSD. As you can see from this graph, SSD is primarily researched online. Now I'd like to share and show some of our efforts to create SSD market and how we keep it alive and active. Let's first turn our attention to word of mouth to create buzz around SSDs and how we communicated this new technology and product in an easy to understand way. Please meet our SSD angels.
No, thank you. I really can't. I'm sorry.
All right, boys, let's go.
Take it on.
Yes, please. That would be great. I'm a little bit late, so...
No, sometimes a little slow, I'm afraid, but we'll do as fast as we can.
Okay.
There we go.
saw significant pickup of this viral video, and such that a member of legendary band Pink Floyd, I think you guys all know about it, and then he actually picked up our SSD Angels video and posted it to his Facebook page because he liked the concept of it very much, so much. He liked it because it does not say about difficult technology. Instead, it talks about people and the new experience and the value SSD will bring on their computing experiences. I guess this is a good example of SSD buzz creation. Communication with our target audience is mainly focused on digital. This is to align with their target audience's behavior. Most of the time, they find and discover SSD product information online and also make purchase online as well. We have created many online banners to communicate the value of SSDs, and let me show you some of our banners. As you can see from the A30 to recent T1, there are banners from static to animation, and also this is the one I like. It's called Site Skin Ads. The banner actually encompasses the whole website to make bigger impact on SSDs. The other medium we heavily invested our digital efforts is in social media platforms, and in our case, it is Facebook. We have the only SSD dedicated Facebook fan page since 2011 and have engaged with well over 720,000 SSD fans. Let me show you some of our Facebook fan engagement, all in the name of promoting awareness and education around these great products. We normally create 3 or more than 3 or 4 contents and post it to our Facebook fans. When we have absolute confidence in the value of SSDs and its benefits to our target audiences, we have to go beyond digital to create more contact and touch points with them. For each product we launch, we created key visuals and print ads to create awareness and educate the market in an easier way to understand. Let me show our print ads and explain their key messages briefly. I think you remember this product. This is a 470 launched in 2011. This was our first consumer SSD. At that time, our message: when we have headache, we take a pill. When we have a problem with PCs, we should have SSDs. Simple as that. This is print ad for SSD A30. At that time, we tried to give another alternative option to older PCs. We could buy a new PC anytime, but here we give people alternative option that your older PC can be transformed like a new PC. Fast, more reliable with the Samsung SSD. This is for A40 series. This is one of my favorite. You know, big city like Seoul, this is what we saw very often. Big traffic over there. But at the other hand, at the solid state drive, as you can see, we can drive at the speed of light. This is for printed for A40 Evo. With A40 Evo, we focus on lifestyle benefits that come from enhanced productivity and time saved thanks to SSD. As you can see, people with SSD without HDD. It's very obvious contrast. This print ad is actually to our internal employees is one of their favorite for A44. I often think SSD is like the engine of PC. So this print ad was actually shot at the real engine room of high-end, very powerful, and also very expensive sports car to show performance at a different level. This is for our latest product, which we are selling now, A50 series, with the world's first V-NAND SSD, A50 Evo actually, it's 2 rabbits. It tried to set a new standard of performance and endurance. And for A50 Pro over there, is indeed was a big step ahead with the V-NAND technology. We are probably the first and the only brand actually who bought a premium space on Time magazine. This is cover of Time magazine. And if I flip the magazine like this, here is our T1 advertising, right next to table of contents pages. We also did outdoor advertising on international airports in Beijing, Frankfurt, San Francisco as well. Thanks to this awareness and education investment we have made, and of course a great product of our SSD product, we are getting the most positive reviews and awards from you guys. For this, I thank you for you very much. We are also the most searched SSD brand on Google. This data is from last month's study we did with Google. There are over 1 million SSD searches monthly in the Google US alone. And of those 1 million searches, we may say that about 420 of those searches are for Samsung SSDs. I'd like to shift gears a little bit and talk about big data analysis briefly. In 2012, we did big data analysis for SSD discussions and found out that who the primary users of SSDs are and targeted them for the Sum of Samsung SSD campaign. Within just 2 short months at that time, we saw a great result that we became #1 SSD brand in Italy, which participated in the campaign. We are open and continue to work on big data analysis to better understand our users' needs. As you see from this slide, we are the biggest part of SSD market and also the biggest part of SSD discussions. Indeed, SSD itself is big data, and we make this much bigger with our investment and efforts on advertising, videos, content, social engagements, events like this, global summit, etc. So that people can talk about more about SSDs and creating bigger data on SSD. I'd like to end my presentation with the things we share together. To us, SSDs are it is excitement. People are excited by the benefits they experience from SSDs. It is enthusiasm. Needless to say, you and I, we all devote our efforts and energy to SSDs. And promises this great product and technology will bring to us. And we believe in the values of SSDs. Thank you for your time and attention to my presentation. Now I turn mic to DY to continue his presentation. Thank you.
I'll just just like to say again about the last part, right? This SSD is an industry, right? It's not just about manufacturers, it's not just about the consumers, it's really about the whole industry, everybody in this room included, right? So, just want to say again, how much we appreciate everybody being here today. So together, let's talk about the next era, the new era paradigm. Right? We know that the pace of this industry has been really tireless, right? From big data, IoT, 4K, UHD streaming. These are really words that are now common in our vocabulary. But along with these new perceptions, we think that the industry requirements, along with everyday consumer expectations, are starting to shift. Just a month ago, with the help of Google, we conducted a consumer survey which revealed that the most important factor when considering SSD purchase was capacity, followed by performance. Now we think this is a contrast from only a few years back when cost was on top of this list, right? That was very interesting to us because this is somewhat of a breakthrough for SSDs, right? No longer are consumers dismissing the idea of purchasing an SSD solely with the perception that they are too expensive, right? They're starting to look at other dynamics. Of course, pricing will always play an important role. But now we think that the average consumer is beginning to understand and really appreciate the values of an SSD. And this is a great thing. For us, the foundation has always been in leading the market by providing the right solutions in a timely fashion. Last year, August, on this spot, we introduced the world's first V-NAND consumer SSD, the 850 Pro. And the 850 Pro continues to spearhead our lineup as the top performing SSD. Since then, our primary V-NAND production facility in Seoul, China has ramped up. This 270-acre facility is really equivalent to 100 football fields, will continue to serve as the backbone of V-NAND production. And that really has enabled us to incorporate the V-NAND technology to our entire retail SSD fleet, right? Starting with the 850 Pro last August, the 845 DC Pro, which was for the enterprise, and then the 850 Evo, including the M-SATA, M.2, and so all the way to our portable SSDs and our latest PM and SM863. And this year, we expect to ship over 13 million units of branded V-NAND SSD for the aftermarket. And we think that this really signifies the success of this technology. Probably most of you are aware that just last month, during the Flash Memory Summit at San Jose, we were really proud to announce the successful development of the 256 gigabit 48-layer V-NAND, which will now be our generation V-NAND. The benefits of this new V-NAND will also open up new possibilities, right? Such as the PM1663, as the name suggests, it is going to be a 16 terabyte SAS SSD for data center application. But today, we'd like to show how the third generation V-NAND is going to impact our consumer lineup. This is where we're going to focus on. Early next year, our flagship, the 850 Pro and the the 850 EVO will be made available up to 4 terabytes of capacity. Right? This is within less than 12 months since we launched our 2 terabyte about a couple of months ago, that we'll be able to double up the capacity. The 850 EVO M.2, currently restricted to 512 gigabytes due to its small form factor, will also double to include the 1 terabyte solution. Our transition plan, right? Currently, we have started mass production of the 3rd generation V-NAND, and it's our target to fully ramp up within the Q4 business timeframe, starting with the 850 EVO, along to the rest of our retail SSD fleet. Right? So I think everybody could have guessed, right? V-NAND is very important to us. And we're certain that this technology will continue to play an integral role, not just in our own success, but the success of the industry. And we understand how sometimes these new technologies can often get a little bit confusing. But we feel very strongly that the V-NAND technology is very important, and we would like for the consumers to know the benefits of the V-NAND technology, and that's why we are starting a campaign, a communication campaign around this. Currently, in the media, as you all know, we're using a lot of terms, right? 3D V-NAND, V-NAND, or just 3D NAND and so forth. We're going to start beginning by simplifying that, right? Just V-NAND SSDs. We are going to brand our entire lineup, starting from the packaging and also online communications with V-NAND SSDs, because we feel that there needs to be a distinction, right, between V-NAND solution SSDs and regular planar NAND SSDs. We feel the benefits are there. We feel the benefits should be relayed to the consumers. Considering the scalability of V-NAND, our 4 terabyte drive is only going to be the beginning of this next new era. I think our campaign slogan sums us up pretty nicely. Stack cell above cells, build technology above technology. Now it's time when we're going to introduce to you the 950 Pro. Finally, the 950 Pro will be the NVMe SSD solution for consumer client PC. NVMe, or non-volatile memory express, is really the new storage protocol that's optimized for NAND flash memory. Again, this is something totally new. What this really signifies is a clear break from the past, right? Where the computing architecture, the storage computing architecture was bound to the SATA interface and the ULTI protocol, designed for those mechanical spindle drives. We see that in reality, mechanical drives really ended with the adoption of SATA 3, right? And that's when SSDs were the only storage devices that could really maximize the potential of 6 gigabits per second. And although the multi-lane PCIe Express took sequential reads to a new height, there was still that ULTI protocol that would remain as the bottleneck. But now, with the new NVMe protocol, we will make a clean break from the past to unleash the full potential of NAND flash storage. But we ask ourselves the question, why now? Right? Because if you can remember, just a couple of years ago, here at the summit, one of the sessions was about NVMe technology, and we talked about the clear benefits of what this technology would bring us. But really, it's about compatibility. Right? And the SM951 was the first pure NVMe SSD launched this year through the great collaboration with our partners. However, for the consumer market, only recently has the pieces started to come together to form the right environment for NVMe adoption. With the launch of the Skylake, the latest motherboards this year will provide BIOS support for the new protocol, while Windows 10 will also round out that ecosystem by providing the driver support that it needs. So we felt very strongly that now is the right time. This is where it's going to begin. Let's look at the key components. The 950 Pro is going to have the UBX controller. Also, we're starting off with the second generation MLC V-NAND, and also the low power DDR3 DRAM. Right? Just a reminder that all Samsung SSDs, the components and the software are made in-house. The form factor. It is going to be an M.2 form factors, 22 millimeter in height and 80 millimeter in length, which is really optimal for ultra-thin laptops with the MP connector. Capacity. In the beginning, the 950 Pro will be available in two capacities, the 256 gigabytes and the 512 gigabytes. And as I mentioned before, right, as we transition to the new 48-layer V-NAND next year, there will be the 1 terabyte available for this drive. Performance. This is the core differentiating factors with the rest of the SSD lineups today. But first, I want to note that the interface on the 950 Pro will be a PCIe generation 3.0 on 4 lanes. Right? This will provide up to 4 gigabytes per second of bandwidth support. Sequential performance. What we are looking at currently is our flagship model, the 850 Pro 512 gigabytes, right? 550 sequential read and 520 sequential write speeds. And you'll see there the limit of the 6 gigabit per second. Without that barrier, the 950 is going to unleash up to 2 megabytes per second read and 1,500 megabytes per second write. That's almost a 5 times increase and almost a 3 times increase on write. Right? So this leap is really just tremendous. Random IOPS. Right? In previous, random performance were really limited and bound to the command qdate of the ARCI protocol. With the new NVMe protocol, the 950 Pro, random reads will triple to 300,000 IOPS. You'll also notice that there is a small increase also in the random writes. So, this morning we did a test just next door, right, to see for ourselves if this really came out. Right? This is the official specs for the 950 Pro, so we're going to show you here together of a video that we shot to prove these numbers. So let's take a look. So what we're seeing here is the 850 Pro, right? 561. Okay. And here we go. 2,500 megabytes per second read. At the bottom there is the IOPS. This is the crystal mount display. And after a session here, the room will be available for everybody here to check for themselves, right? There we go, 1,500 megabytes per second write. Okay. So everything holds up. Very lucky. In the user scenario benchmarks, right, the breakaway continues. For the PC Mark 7 on the 512 gigabytes, the points double. On the PC Mark Vantage 512 gigabytes, we see that it almost triples in points. The newest Samsung Magician SSD utility tool will provide support for the 950 Pro. Right? This is going to be the version 4.8, and it will be available next month. So there will be an update for the new product. NVMe driver, there will be a proprietary driver for the 950 Pro. However, there is current support for Windows 7, Windows 8.1, and Windows 10. They do provide universal support, but it's just that at the beginning, since there could possibly be compatibility issues, we want to make sure, right, that everything works as advertised, and that is why we have our own driver as well for the consumer to choose. We also have plans to broaden that support for other operating systems, also for the Linux and the Windows Server, so we're currently working on that. The 950 Pro will be backed with a 5-year warranty. And we feel that with these kind of new performance levels, we expect our users to be more involved in higher workloads, right? So more data processing in less time. Therefore, we're expanding our TBW, total bytes per written, to 200 terabytes and 400 terabytes. So this respectively is really a 50 terabyte and 100 terabyte increase from our current 850 Pro. Products will be available next month in October. Pricing begins for the 256 gigabyte at $199. 349 for the 512. the 950 Pro isn't going to be alone for long, right? We'll soon be backing up with our NVMe solutions with the PM1725 data centers. This full half height, half length, added card type will be based off 8 PCIe lanes, where we can expect up to 5,000 megabytes per second sequential and 1 million IOPS speeds. So, at this pace, we're seeing the industry expand, right? No one can be entirely sure where or how SSDs will be represented in the next 3-5 years. But to us, it's really clear, right? V-NAND and NVMe technology together is going to make that happen for us. So thank you for listening. Thank you very much. Have a nice day.
Mr. Jong, for showing us how a V-NAND combined with third generation SSD will bring about many changes, and also to Mr. Seo for your presentation on Samsung's contribution to the growth of the SSD market. Why don't we give Mr. Seo and Mr. Jung another round of applause for their presentation. Our next presentation is on the NVMe effect. Let me introduce Mr. Ryan Smith, Director of Samsung Semiconductor, onto the stage. Let's welcome him with a warm round of applause.
How are you? I look like that guy? You know, this is our 4th annual summit, and coincidentally, this is also my 4th year at Samsung. And I feel very spoiled to be here at Samsung, because in those 4 years, I've seen more innovation happen in those 4 years than I saw 10 years in the enterprise storage space prior to that. Simply amazing. Every single year, we always one up the level that we keep delivering to the market. So I'm very excited to be here. I want to thank you guys for all having the time to come out here and be with us. I know time is very scarce, and that's actually what NVMe helps solve. You know, being here with all of you in the room makes me feel like I'm at the center of the tech universe right now. What's interesting about that is a couple years ago, quite a few years ago actually, we thought that we were at the center of the universe. But obviously that wasn't correct. And over time, as our technology improved, as our models improved, our ideas improved, we realized that the sun was actually at the center of our solar system, and we weren't in fact the center of the universe. So let me shift gears for a second. That actually took us over 2,000 years to realize that, by the way. 2,000 years. So as we look at the PC side of things, the PC became mainstream in '92. PCs started to enter every household. But really what entered PC into everybody's home was the internet, connecting you. It was that social effect of requiring you to have a PC, otherwise you wouldn't be getting your friend's email or your Facebook update. Then along came the MP3 player. Now that people were ripping their CDs onto their computers, they wanted to be able to play them in a nice, convenient way. The MP3 player came out. Then the smartphone. Smartphone really made us start to question whether this was our PC, whether that was our PC. 2010, we had the tablet, as well as the TV join in on the fun. All of these things being connected together, and now it started to become ambiguous as to where data was created, where data is consumed. So in reality, what we started to realize is that the cloud was the center of this, connecting all this data together. It doesn't matter where you create it, where you consume it, there needs to be a way for you to get that data in and out of each device so that you can pick the right device for the right time, the right job. It only took us 20 years to realize this truth. This truth has actually resulted in massive data growth. Let's just think about this for a second. It used to be one PC per household. That meant when you went home after work or after school, you'd be able to hop on your computer and generate content or generate data, consume content. But throughout the day, you weren't generating any content. But this changed. Multiple devices now per household member. Every single person in the house now has a device. Even my 5-year-old and my 3-year-old has devices that are generating content, consuming content. They're learning on these devices. Think about the data explosion that now is possible because of this. I can create data while I'm sitting there. You can create data while you're sitting right here. You don't have to wait until you get back home. Profound effects. Also, now that we're connected to all this data, now we've kind of become accustomed to having all this data all the time. Now we start demanding perfection. We want to improve this, improve the quality of the data that we're consuming, and improve the quality of data that we're creating. So as we went from 480 to 1080, we started noticing significant differences in the quality of the picture. But as we keep demanding bigger and bigger screens, you start to notice that you start seeing the pixelation and whatnot. So this resulted in 4K video becoming a necessity. The amount of content being created by this is remarkable. And if you want to think about it, sometimes people think that there's not a lot of 4K content available yet. But what I'd like to say is that a lot of the streaming services have actually started adding more content, but more importantly, you have plenty of content already on your phones, already on your PCs. 4K is roughly 8 megapixel. 8 megapixel is on every one of your cell phones today. You are all creating 4K content, and you're not enjoying the quality of that content without 4K. The amount of data is phenomenal. But, as we talked about, you need to get data in and out of these devices. You took the picture on your phone, you took a 4K video on your phone, you want to play it on your TV. You need to do this fast and quick. Any type of lag destroys the user experience. So we need faster connectivity. So let's take a look at a couple devices. So mobile data speeds, as we've gone from 2G all the way up to 4G, we have 100 megabits per second. I cannot believe those speeds. I still remember the days when I had a 2400 baud modem. That's 2.4 kilobits a second. Now we're getting this data right over the air. With 5G coming, we're talking about 10 gigabits a second, or 10,000 megabits per second on your phone. Wi-Fi speeds, so looking at all the computers that you have open right now, getting data in and out of your system as we fall from AV, went to AC, we're talking about 1,300 megabits per second in your PC. With AD on the horizon, we're talking about bringing that up to 7 gigabits per second. Incredible speeds out of a personal computing device. Still gotta love wired. Wired still sticks around. It's very stubborn. But as we go from USB 1 all the way up to 3, we saw great leaps and bounds in speeds. With the latest Skylake processor, we're now seeing 10,000 megabits per second. 10,000. But with Thunderbolt 3 now being a standard in PC chipsets, you're now talking about 40,000 megabits per second in a consumer PC. This once was only afforded by servers and data centers, and now it's sitting in a computing device that you can pick up at Best Buy. Storage. So as we went from SATA 3 gigabit to SATA 6 gigabit, it was not enough. We needed something faster to keep up with all these interface speeds. 32,000 megabits per second. And if we compare this to some of the technologies that we just talked about, you notice that SATA is actually holding us back from offering a well-balanced system. I want to just mention, it's not just about speed. SATA versus NVMe, let's just take a quick look. So the number of queues that SATA HCI can support is actually 1. You can have 1 queue or 1 line for data. PCIe can handle 64,000 queues. 64,000. And the number of people or number of IOs that can wait in line or wait in a queue is only 32 with the HCI, and again, 64,000. However, it's hard for me to conceptualize what this means. So, many of you, like myself, had to come into Korea and stand in a line, customs. Nothing would be more frustrating to get off that plane after 12 plus hours and realize there's only a single line. I'd be very upset. And that's exactly what we've been dealing with SATA HCI. NVMe essentially gives you multiple lines so that we can efficiently get data in and out of those devices. It's a profound difference. This will have a big impact. Right now, when you issue an I/O on let's say you have an 8-core system, 8-core CPU, and you have an application well balanced, or you have multiple applications well balanced across your cores. Each of those applications actually have to send all the I/O to one of those CPU cores so that it can issue the command. That's how inefficient it is. Now, what if the application could instead just utilize the core it's running on to establish its own queue? That's what NVMe is enabling. It's making it more efficient. So let's take a look at how this is going to impact the PC. All of those things that are sitting right on your tabletops right now. So SATA, believe it or not, was actually fast enough to keep up with yesterday's PC. With wireless and USB 2. You notice a hard drive can actually go faster than that. So getting data in and out was not necessarily a problem. However, with the new chipsets that are now available, the SATA hard drive, for the first time in history, is now not able to keep up with getting data in and out of your device. First time. And SATA SSDs was actually fast enough. However, we're holding it back from its full potential. It cannot keep up with getting data in and out of your device. NVMe is the answer. NVMe is not a luxury anymore. It's a requirement to keep a well-balanced architecture. In order to design a PC that can get data in and out as fast as these interface speeds are, you require NVMe. Why have all these upgraded speeds if you can't enjoy it? Let's take a look at a couple examples. Copying some files. You just went to an awesome event in Korea. Go back home. Now you need to transfer those files onto another computer, one of your colleagues to go process. That once required you to copy it onto a USB stick perhaps in the home, copy it back over, and that could take 6 to 10 minutes and even longer. Very painful. With USB 3.1 and NVMe, we actually reduced that down to 10 seconds. We are talking about allowing people to be more productive and save time. So it's not just about being fast, it's about saving time. Another example, transferring photos. But let's say we, instead of using USB 3.1, use Thunderbolt 3, which actually lets us enjoy the full potential. I'm sorry, got ahead of myself. Fast like NVMe. So, 177 seconds with a hard drive. Going over to Thunderbolt 3 with NVMe, you're talking about, again, bringing that down to 10 seconds because we're able to do this over Thunderbolt 3 and really see the full potential of what NVMe offers. But something that's often overlooked is just because it's faster doesn't mean that it consumes more power. It actually consumes a lot less power. And let me help you understand why. So the idle power and the active power are actually quite significantly different. So roughly 5 watts for active power, you're talking about 2.5 milliwatts for idle power. Just to change it to the same metric, you're talking about 2.5 milliwatts and 5,000 milliwatts. Quite a big difference. If I can get to idle faster, that means that this SSD can go back into idle mode, idle power savings mode, and actually save you quite a bit of difference. Meanwhile, the hard drive keeps running. for 177 seconds. You do the math, that's 95% less power simply by transferring data faster. So it is not only about enjoying the speeds, it's about giving yourself more battery power. So we just looked at the PC. Let's look at the data center and enterprise impact. After all, as we connect to information out on this cloud, it actually impacts the data center and enterprise quite significantly. So as we demand those bigger TVs, 55-inch, actually that's kind of small now, isn't it? 80-inch, bigger. So 1080p actually requires 6 megabits of data being transferred, compressed, in order to get that image onto your screen. But as we move to 4K, that's 20 megabits per second. So that's 3x the amount of data required to draw that beautiful picture on that screen. Let's take a look inside the cloud to see how that's possible. So, if you use SATA SSDs, notice I'm not even using a hard drive example because it would just be too complicated and confusing. So if I wanted to support roughly 3,000 to 4,000 subscribers watching a 1080p video in a 1U server, I can actually do this with 5 SSDs and 20 gigabits of network connectivity. Very common configuration right now. However, for 4K video, it's going to require me to double the amount of network speed, double the amount of SATA SSDs, and double the amount of servers that I have. If you think about this, if I'm not only supporting 3,000 to 4,000 users, I'm supporting millions of users, you're talking about doubling the size of your data center. Obviously, we could do this. Why is NVMe needed? Because if we didn't have it, you would talk about doubling the size of a data center, which means potentially doubling the cost of the service. Nobody wants that. You want to get 4K for the same price as 1080p or pretty close. So, you take NVMe, and we could do this in a single server using 80 gigabits of connectivity and 10 NVMe drives, which fits very nicely into a 1U server. Let's take another example. If you want to optimize your data center, typical configuration you might see is where you have a RAID card. Let's say you have 4 SSDs, you're striping them, you have 3.2 terabytes. NVMe allows you to do that in a single card. So now you can just take out the RAID card, put in an NVMe card, don't even use any drives. This is very efficient, so we're basically miniaturizing what was once possible by larger configurations. Again, it's not necessarily all about speed. Having a profound impact on the data center. But the story gets better. When you do this, you actually use less power and you get more performance. Makes sense. NVMe is enabling this kind of creative way of thinking about how to solve problems. It's simplifying how to do things that we did yesterday with racks and racks. Now we're doing it on a card. This really is sparking possibilities. So if we look at time and how SSDs have evolved since I've been here and even prior, SATA has been holding us back. Every time we come out with a new SSD, it's just inching along, inching up a little bit. We're not having profound impacts on megabytes per second or IOPS. But SATA is what's been holding us back. It was time for us to grow into a new home, a new shell. We needed to explore new opportunities. So we busted through that barrier with the NVMe SSDs. The SSD we just talked about is capable of 20 gigabits per second. Obviously, we talked about how it's on PCIe Gen 3x4. It's capable of much more. We're growing into this new home. We've kind of relaxed a little bit. Now we got to grow into this new capability. But as we expand through that and go even beyond to PCIe Gen 4 as that comes out, think about what's going to be possible. Think about what industry we're going to disrupt next. I talked earlier about how we went from one PC per household to multiple devices per household member. There was one thing missing. The house itself wanted to join in on the fun. Every single electronic device in your home is going to be connected to the internet. So not only while you're awake creating data, but also while you're asleep, your house itself is creating more data. Whether it's sleep monitors, whether it's your washing machine, your refrigerator, your outlets, your security system, all of this is now creating data. It's time for us to think a little bigger. By 2020, we're expecting 25 billion devices to be connected to the internet. This is the whole IoT thing. When you start thinking about it, multiple devices per person, multiple devices per household, you can see how this really does quickly add up and become a very believable story. But 4K won't be enough. NVMe is going to help us get to 8K and beyond as we grow into our new home and offer even more performance. NVMe is going to help us deliver perfection to every single house in the world. Think about this. What once was only afforded by the wealthy, by the large corporations that were able to attack whatever particular niche in business they were in, which would take many, many data centers or large racks in order to achieve what now can literally fit in the palm of your hand. That is a profound change in how you start rethinking how you design new architectures and what you're going to be able to disrupt. Think about different applications that were once again only reserved for, let's say, the financial market where they have higher profits. But now, instead of doing crime analysis, why don't we do crime prevention? Analyzing data real time and quickly being able to analyze whether somebody is about to rob somebody on the streets. This will be possible when you have large amounts of data, you're able to process amounts of data, you're able to look up, for example, the criminal history of the person in the video camera and do this without any lag. NVMe is part of the backbone that helps us get to achieve these type of new innovative technologies. Think about surgical procedures. Being able to have a doctor have real-time information displayed right in front of him while he's operating on a patient. Self-driving cars. I don't know about you, but I don't want any lag when it's deciding whether it's taking a left or a right into incoming traffic. It can really make the difference between life and death. No lag. But the most exciting to me is virtual reality. Virtual reality in itself is pretty vague. I mean, it covers a lot of topics. But let's take a look at that surgical example once more. Imagine a doctor in Korea putting on some goggles, operating on a patient in the US, wearing some gloves, and again, without any lag, operating remotely. So NVMe isn't going to give you the ability to transport yourself, but it virtually will. Imagine not being able to tell the difference between whether you're here or in the US within a matter of seconds. Imagine attending this summit 5 years from now, virtually. That is cool. That is the type of thing. I want us to all start thinking bigger about the types of things that will be enabled by NVMe. It only took us 2,000 years to realize the sun was the center of our solar system. It took us 20 years to realize that the cloud was the center of our tech universe. And it's only going to take 2 years for you to start to see some of the cool innovations that people are going to do with this technology. Thank you.
It's upon us. The new era of computing we've been dreaming of.
enterprises and consumers.
Yes, the video made us look back on the previous Samsung SSD Global Summits held in 2013 and 2014, and I'm sure it brings back plenty of good memories. Now it's time to start our Q&A session, so we would like to invite the people who will be answering your questions up onto the stage. Ladies and gentlemen, please welcome our presenters and responders who will be answering your questions with a big round of applause. I would like to turn to Mr. An-Soo Kim to introduce our presenters.
Thank you. Let me start with introduction of the panels. On my left-hand side, Jin-Man Han, Vice President, who is from SSD development team. And next to him is Chanik Park. He's Vice President and Head of Software Development Team in our Solutions, SS Solution Group. And Dr. Daniel Lee is Head of Flash Planning, and he's a Vice President. And Mike Mang is Dr. Mike Mang. He's the Vice President of NAND Flash Marketing. And Ryan Smith, as you know, Director from Samsung Semiconductor American Headquarters. And myself is An-Soo Kim. I am Senior Vice President. I'm the Head of Brand Product Sales and Marketing Team. Thank you very much. So, shall we begin? Mike, someone can pass the mic.
Hi, hello. Peter van Linden from Data News in Belgium. I'm wondering what is Samsung's stance on SSDs in the data center? Will they take over the data center completely, or just partially for media-specific purposes or high-performance purposes? What's Samsung's take on it? And well, if SSDs will take over the data center, well, will that happen?
I think we have a data center expert, right? Mike Mang or Ryan?
We think that we will completely replace all the HDD in the data center with our SSD. Completely displace. We think that already over the 50% of the reading the data center guys, like Amazon or Microsoft, with the mega data center guys, they are replaced all the HDD with our SSD.
I mean, you see some of the trends that are occurring, like the 16 terabyte SSD. Lots of interest in that product all across the board, whether you're talking about traditional tier 1 players, talking about hyperscale data centers, just massive interest in this. Again, it's not just about the cost per gigabyte, it is about the other costs that go into data centers like cooling, space, power, and all of that. So SSDs actually do have more an advantage, even though it's not exactly cost parity with some of the cheapest hard drives out there. So you're going to start seeing massive disruption. We already are.
I wish I could share a lot more about what these are, but a lot of the conversations are very confidential. But yeah, as Mike was saying, we do expect a huge disruption in data centers.
Okay, not all desktop users have an M.2 slot. Are you guys going to include an adapter for desktop usage?
M.2 adoption in desktop usage.
Actually, it's the current slot for the SSD is the mainly 2.5 inch in the desktop, and the attach rate speed is the slow than notebook because the desktop itself is the bad. The price is very low, so the price of the SSD is sensitive to the desktop. Anyway, but it takes some time compared to the notebook. But eventually desktop also adopt the M.2 slot.
The second question that I had is, M.2, some of the current generation SSDs, they throttle when they run into heat problems, which is fairly common in notebooks and other applications. Dynamic thermal throttling is, a good addition, but throttling is almost an emergency procedure in the first place. What are you guys doing to mitigate the performance impact from thermal considerations?
Yes, I'll take the question. We adopted a new algorithm for throttling technology, so it is a little bit different from past products. We have been improved the algorithm, so I think the heat problem for this M.2, this is very small form factor, so we know that it's very susceptible to any thermal issues, but we don't see any issues at all after we adopted the algorithm. Also, the V-NAND has very low power compared to the planar NAND. So overall, it's going to be about below 6 watt, and we don't see any huge performance drop after long times of data transfer.
On the subject of V-NAND, some of your competitors recently have been quite vocal saying that charge trap can suffer from charge spreading and rapid charge loss, which of course isn't good for endurance, and in comparison to floating gate 3D. Do you think that's an accurate statement?
We have been mass producing this V-NAND for, I think, more than 2 years. We just shipped 2.2 million V-NAND based SSD last month. And we figured out all the issues that's been happening in the mass production stage. We basically believe that we ironed out all the irregularities of the V-NAND technologies. So we don't see any problem.
Okay, thank you.
Okay, who's next? Maybe center.
Hi, this is Koen from Hardware Info in Holland. You just announced the 4 terabyte versions of the 850 Pro and 850 Evo, and that they make use of the new 3rd generation 48-layer V-NAND. I was wondering, will the 2 terabyte and other capacities also make use of the new V-NAND next year, or will they stay on the 2nd generation?
Let me answer that. Currently, as you know, we are using 2nd generation 32-layer V-NAND to our SSDs. But when there is a mass production of 48 layers of V-NAND, we are going to transition to that NAND. So all SS formats will have 48 layers of V-NAND, 3rd generation.
Will that have any influence on performance?
I think the performance will be same or better, so we don't see any degradation in performance.
So we can just add, not just moving up the 48 layers, we are also focused on disruptive, innovation in power and performance. So performance will be also increased, so there is no less performance drop by moving to V3 NAND.
And the second question I had is the 950 Pro has 5 years warranty, and the 850 Pro had 10 years. Why did you go back from 10 to 5?
That's because NVMe is very high performance, so we just increased the TBW from 150, in case of 128 to 256 gigabit, we increased from 150 to 200, And this is also first generation NVMe. I do believe that in the future you'll see long warranty as same as 850 Pro.
I think as DY Jung in his presentation explained about our warranty policy on 950 Pro, I think he explained that 10 years to 5 years, but we increased the TBW to 200 for 256 gigabyte and 400 TBW for 520 12 gigabyte. So we thought that the NVMe users may require much heavier workload. So I think allowing more TBW might be suitable. And also this is, as he said, is first generation, so we have to see the performance.
But aren't you afraid that end users will think that Samsung has less confidence in the new product because of the 5 instead of 10 years?
That should be a consumer's choice whether they take the longer term 10-year warranty or the higher TBW. So we'll see. Who is next?
Lee for the Wall Street Journal. We have two corporate-related questions. The first one is about market share. During the presentation, Mr. Jung briefly mentioned a figure like 336 million units, so 200-something gigabyte SSDs. Just wondering how much of that pie Samsung is planning to claim. So we're trying to figure out how much of a market share Samsung is planning to have in the SSD market. And my second question is how big will SSDs, proportionally speaking, take up memory revenue for Samsung in the long term, or either in terms of profits?
I think in terms of market share, we have to think about the total market share of Samsung electronics memory business, which is including OEM and aftermarket SSD. From my side, I can talk about our market share in aftermarket, which is retail and small and medium business. We have average 50% market share worldwide in aftermarket, retail and small and medium business. That's our current market share position. We are at #1 right now. And then including the OEM, right? Mike mentioned
it's over the 40% total. Then the flash market share is over the 40%.
Yeah, and I just want to add a little bit of clarity. That example that was given in the presentation for 336 million SSDs, that was taking total NAND and dividing it by the average capacity. So that's not the actual number of SSDs that shipped. It was just to give you an analogy or help you understand how big 84 billion gigabytes is.
In your second question, is the revenue-wise, in our old NAND flash revenue, the portion of the SSD is over the 40%.
Next question.
Hi, Orestes Bastonis, PC Gamer UK. I was just wondering if you could give us some more details about the controller in the 950 Pro. I think it's called the ULX controller. And a bit about, has the amount of DDR3 memory changed from the 850 Pro?
So your question is, we are using UBX controller, which is the name of our controller for 950 Pro. So your question is about the UBX controller? How?
Yeah, how fast is it running? How many cores does it have?
How many cores and how fast?
Details, really?
So our UBX controller is our the native controller, it has 3 core inside controller. So one is dedicated for host and the 2 is dedicated for NAND side. And we use the LPDDR4 to maintain the low power. So it is native PCIe Gen 3 and Core 8. And it has LNDAC2 kind of support. So it's already certified in UNH, the PCIe, the signal integrity. So what else kind of information do you need?
What speed is it running at?
I guess it's over 500 megahertz, and it also has 8 channels between controller and NAND.
Is that answering to your questions?
Yes, thank you.
Hello, this is Allie from Bloomberg News. Do you think your new advanced NAND flash chips can invite more Chinese users in the coming year? And where do you see demand coming from by markets?
Especially Chinese customers.
Yes, Chinese customers, and what markets do you think?
It's the mainly notebook and data center. Notebook and data center.
Chinese market is exactly following up the US market. The first notebook area, Chinese market is blossom up. And the second, the main, increase come from the mega data center. For example, the BAT is the main user of our SSD in cloud computing and cloud data center. That's the increase.
We do really hope to see more Chinese customers buy our product because most of our V-NAND-based SSD are coming from Chinese by now.
Are you actually getting more orders from Chinese vendors now, or do you expect more demand coming?
We expect more. We hope to see more.
So
more
it's not in discussion yet?
It's increasing right now, the CGL rate is, compared to other countries, it's more amazing.
Growth rate is very high. That's fact.
Okay, thank you.
Okay. Gentleman in the second row.
Billy Dallas and Optech. You're introducing the 48-layer V-NAND, your 3rd generation, under an existing product family brand with the 850. Why is it that you're not using a new product family for what's a really dramatically different memory that you're putting into these drives?
So usually in our NAND technology, when it first comes, it starts from the consumer area and moving up to, the PC and the data center and the enterprise area. By doing that, the technology got matured and it comes in a really good way. So that's the strategy we maintain like that way. So any within early next year, we're gonna completely change and transition into the V3 NAND. So it's in the process of migration.
I have to answer that. I'm the person actually who decided on keeping the same model name, even though we change from 2nd generation V-NAND to 3rd generation. We just introduced the 2nd generation V-NAND last year, and we saw like the benefit of the V-NAND for the 850 is almost same, and we can offer much higher value to consumers. But by changing the model name again and again, will confuse the consumer. So we decided to keep the same protocol, but we will give you more detail right at the time when we switch the model from the 2nd generation V-NAND to 3rd generation V-NAND. So from a consumer standpoint, there is no big difference. That's why we are keeping the same model code. my side.
Hi, Nicole Scott from Mobile Geeks. I just had a question. I got asked a couple of times on Twitter, so I just wanted to confirm that the 950 is compatible with Windows 10 for all modes, and I'm sure it is. But also, when is the 850 going to get a rapid mode support?
So currently the NVMe Windows 10 inbox driver support completely, our NVMe, and even 8.1 the inbox driver support, and Windows 7 the hotfix software also support. That's your first question, right?
And rapid support for Windows 10 will be only October.
Perfect, thank you.
Okay, Center.
Hi, Chris, I can say that. What is holding back you guys from releasing a driver for Windows Server and Linux, given that you've got NVMe drivers already for those operating systems in your enterprise products?
So the reason is, we know how the SSD operates better way, likely the Intel inbox, the IRSD, right? So that's why we also have, our proprietary, the NVMe driver. So if the really high performance, kind of boosting you want, maybe you can choose either our, the device driver or just the general, the inbox driver. That's the option we prepare.
But if I go out and buy one of your enterprise products now, I've got the manual here in front of me showing me how to install the driver for, Linux and Windows Server. What's in the 950 that's stopping that from happening for you guys?
950 is for consumer grade PC client SSD, consumer target.
I can answer. So at the very beginning, we are the first, development company, to prepare this NVMe. At that time, the eco is not ready, so that's why we prepared our NVMe drive and provide to our customers. We prepared the Linux and the Windows Server inbox driver. But now we work together with our, the Microsoft and other, Echo OS builder, so thereby we completely prepare. So that's why, we can, users, prefers the generic kind of the OS, inbox driver, right? So that's the movement we prepare. So is it answer, good answer for you?
Yeah, no, I'll take it.
I think this year we are getting a lot of high-tech related questions. I think pretty surely, we sparked the new technology breakup. Okay, next questions.
Greg Cork from Develop 3D. You say in your press release that big target users CAD users, engineering simulation. Do you have any reference applications that you've tested to see what the different performance between this new generation technology and older generation technology, or you're just presuming that these are good applications?
950.
With the 950, yes.
I think we are presuming. There is a lot of possibilities which we may not know. So I think this is the start of sparking new possibilities. So we'll see how market develops. Person, center.
你好，想请问一下，现在在中国销量三星 SSD 的128、256、122的比例是多少？现在这几个容量的销售比例。
Could you say one more time so that we can hear simultaneous translation?
就是在中国，三星 SSD 128GB、256GB 和112GB 的销售比例，哪种容量更好卖一点？
Okay. I do not have the exact numbers in my mind, but I think the Chinese market, majority of the capacity is based on 128 gigabyte. So if I say the overall market in China, almost 80% of the aftermarket SSD purchases based on 128 gigabyte. But now, also our portion of business is a little bit smaller than that because we are focusing on a much higher capacity. But overall, Chinese market also, the average SSD capacity is increasing to 256 gigabyte. So we see that trend changing. About 500 gigabyte and 1 terabyte from aftermarket purchase is relatively small at this moment in the Chinese market. So as I said, the majority is 128 gigabyte, 70 to 80% of the market. Thank you.
Hi, it's Koen Hardwinkel again. I had one more question. With the capacity of the dies and the final SSDs increasing every year, what are your expectations for the price per gigabyte for the next couple of years?
Can you tell us? It's a tough question. I think maybe you saw from some of the graphs that we have shown at like a summit many years. You know, the curve slowing down. As DY said, what was your current US gigabyte per dollar per gigabyte? 40 cents, 38, right? 38 cents. That's a retail the dollar, the cost in USA. So 38 cents per gigabyte right now. But I think it is keep going down as technology and also demand increases. So we don't know, but we are trying to deliver the best value SSDs to the market.
Can you make any estimation on when that 38 cents will be cut in half again?
Overall, our target is every year the price drive is around 15 to 20%.
Every year 20% less, you mean?
Yes.
Thank you.
Hi, this is Aditya from Times Internet India. Quick question, there have been references of US and China as a market, but we've seen things have definitely improved on the Indian market front as well. Can you just give us a bit of a highlight as to how India is seen in this picture for Samsung as a SSD market? Because India has been traditionally a HDD market. So are you seeing the change happening? Are you seeing that there is a different growth there, possibilities in the near future?
For our aftermarket SSD retail business, one of the hurdles in penetrating into Indian market was the channel availability. We are working closely with some of the retail partners in India to showcase SSDs. So I think the people are getting to know the value of SSD. They get to know the product portfolios. So soon the Indian market for SSD will grow. But right now, we see some of the limitation in the channel distribution. So but in terms of the demand or the value buying from Indian customers will grow. Right now it's still like a, the pretty early stage of SSD market in India. That is true.
And you talked about like 80% is like where the 128 GB of the models are selling in China, sales-wise, right? So do you have any kind of numbers for the Indian market right now pertaining to the SSD product range?
India also similar to Chinese market, so low capacity for the desktop users. That's the main capacity category in India too.
And cost per GB difference, are we talking about similar numbers that you mentioned for the US market? $0.38 per GB or something is what highlighted during the presentation.
I do not have the number for you. Sorry.
Thanks.
第一个问题就是说，我们看到就三星的产品里面已经越来越多的使用那个 V-NAND 这个技术，然后它主要是因为可以一方面提升容量，而且有效的降低单位成本价。那么我想起另外一个技术就是 GLC SSD。我们看到在现在的那个数据中心领域，英特尔把它的那个 GLC SSD 推荐给它的企业客户。那么我想问一下，就三星是怎么样看待那个 GLC SSD？
Current position for the TLC SSD, that is the most focused the product. That means most of our customers now using our TLC SSD from the notebook to even in the enterprise storage guys. So we focus more and more with our TLC SSD. TLC is the reasonable, the reliability, and the most favorable the price than the NRC SSD.
So I wish to add, our V-NAND TLC, the quality-wise, is almost, better than the, Prema MLC technology. So that's why our V-NAND TLC is mostly popular in even data center and enterprise area.
第二个问题是也是关于企业这方面的，就是说在服务器，在一些开放的服务器设计里面，我们看到它里面设计了 M.2 接口的，它使用 M.2 接口的 SSD 用来安装操作系统。那么随着 M.2 接口的 SSD 的容量越来越大，那么如果说只安装操作系统的话，是不是会显得比较浪费？那么这是否也意味着 M.2 的 SSD 它可以在服务器里面发挥更大的作用？
So the main benefit of M.2 in server area, as you commented, the airflow and thermal is very good. And as you commented, currently the M.2 is not widely utilized in server area because of those connectivity issue. And Avago currently has the SFF 8639 compactor and laser card to attach to there. But we are currently working together with our the vendor guys to prepare more popular. So you already see, right, in OCP, Open Computing Platform, the Microsoft announced the new kind of a server platform, right? It used the M.2 kind of NVMe, right? So that's the movement we are currently moving ahead, and Echo will be ready. Because M.2 has more benefit, right?
Okay, we will take one last question. You're gonna be the last one. Okay.
Jimmy, thank you, Max from DC here. Intel and Micron recently said that they've been working on a new type of SSD called 3D Crosspoint, which they say is supposed to be 1,000 times faster than traditional setup. Have you guys been following that, and what do you guys think of that?
We don't usually comment on the competitors' technology, but as one of the main leaders in NAND flash or memory technology, we have been investigating all the possible future memories, and so that's all I can say. We are exploring all the next generation flash memory solutions.
Okay, I think that's pretty much it. One, real last one.
감사합니다. 예, TLC 관련해서 아까 이야기가 나왔는데 그 840 롱홀 모델과 그 OEM 제품에 대한 TLC 작년에 있었던 TLC 이슈에 대한 펌웨어 지원이 지금 없는 상태로 알고 있습니다. 그런 부분에 대해서 어떻게 사후에 지원이 있는 건지 아니면은 최소한 그런 펌웨어 지원이 없다면은 매지션 툴, 리테일 제품에서 사용되고 있는 매지션 툴에 대한 지원이라도 좀 해달라고 하는 게 좀 일반 사용자분들의 지금 저런 목표이거든요.
그러니까 그런 부분에 대해서 좀 말씀 좀 부탁드리겠습니다.
제가 얘기를 드릴게요. 지금 뭐 840 레보라든지 이쪽에 퍼포먼스 부스트 할 수 있는 모든 펌웨어 업데이트는 다 지금 진행이 돼 있고요. 그죠? 소비자들이 다 알고 있고, 지금 여쭤보신 게 이제 840 말씀하신 것 같은데, 840 지금 저희들이 워킹을 하고 있고요, 사실은. 그래서 지금 거기에 대한 솔루션을 내려고 하고 있고, 다만 이제 소비자들 유저 케이스가 워낙 다양하다 보니까 우리가 그거를 전체를 좀 맥슈어 해야 될 필요가 있고, 그래서 여러 가지 지금 테스트하고 이런 걸 하고 있고요. 실제로 소비자들이 840에서 느낀 불만 이런 걸 잘 수렴해서 저희들이 지금 플레이를 하고 있습니다. 조만간 아마 이슈가 될 걸로 좀 그렇게 돼요.
OEM 제품과 노멀 제품에 대한 펌웨어가 나오는 말씀하시나요?
우리 소비자용에 대한 펌웨어가 나오는.
OEM 제품은 소비자용이라고 볼 수 없지 않습니까? 그러니까 기존에 지금 서비스3나 아니면 뭐 노트북 같은 데 지금 들어가 있는 거, 그러니까 소비자가 직접 구매한 제품이 아닌 840 노멀 같은 경우에는 이제 소비자에 판매됐지만 OEM 제품 같은 경우는 특히 뭐 타블렛 같은 데 들어가 있는 거, 서비스3 같은 거에 들어가는 거에 대한 불만이 상당히 많거든요. 펌웨어가 안 나오고 TLC 그런 부분에 대해서
마이크로소프트 서피스에 대한 지원은 현재 마이크로소프트사와 지금 테스트 중입니다. 펌웨어.
향후에 나올
예, 맞습니다. 예.
그리고 이제 MSC 기반의 이제 고성능 제품에 대해서 이제 저용량 제품이 좀 안 나왔습니다. 아까 뭐 중국 시장이나 인도 시장 같은 데에서 저용량이 이제 아직은 더 대세라고 말씀드렸는데 국내 유저분들 같은 경우에도 저용량 제품에 대한 기대가 있습니다. 근데 현재 지금 여기 950 프로 같은 경우에는 2월부터 발표가 되어 있기 때문에 그 저용량 제품에 대한 향후에 출시 계획이라든가 그런 게 있는지.
지금 저용량 제품 있고요. 128GB. 지금 오늘 발표드리는 거는 이제 NVMe인데, NVMe 솔루션은 또 이걸 요구하는 이제 소비자 층을 봤을 때, 기존 일반 소비자하고 좀 다른 층이라고 좀 보고 있고, 그래서 지금 현재 우리가 론칭하는 이 시점에서는 저희들이 뭐 모든 플라이를 한꺼번에 이제 시장에 노출하기 전에 할 수는 없기 때문에 선택적으로 일단은 현재 우리가 보고 있는 NVMe SSD의 목표 타겟, 그러니까 컨슈머들을 봤을 때 256하고 500, 그리고 나중에는 1TB까지 그 라인업을 가져가는 게 지금 합당하다고 봤고, 그런 생각에서 사실 그렇게 라인업된 시장 확대에 대해서는 뭐 그때그때 우리가 대응을 할 겁니다.
그리고 마지막으로 이제 지금 950 프로 같은 경우에는 이제 기존에 지금 일반 유저분들도 이제 해외에서 이제 구매를 해가지고 오시기도 하는 SM91 기반으로 알고 있는데요. 기존에 지금 사용자분들 경험으로는 이제 PCI 방식 같은 경우에는 부팅할 때 이제 그 시간이 더 오래 걸립니다. 산타 방식이랑 비해서. 그런 부분에 대해서 상당히 불만이 좀 있는 것 같은데 향후 그런 부분에 대해서 개선이 되는 부분이 있는지 기술적으로 그 부분에 대해서 좀 알고 싶습니다.
저기 기존의 PCI는 프라이어티 드라이브로 부팅을 시키기 때문에 그렇고요. 저희가 마이크로소프트하고 윈도우 10부터는 인박스 드라이브로 준비를 했고 부팅 타임이 산타 대비해서도 훨씬 개선되는 걸 볼 수 있습니다. 그래서 오늘 엠바고를 통해서 샘플이 풀릴 거로 알고 있는데 윈도우 10이랑 테스트 해보시면 굉장히 빠른 부팅 타임을 경험할 수 있을 겁니다.
Okay, thank you so much for the questions, and I really appreciate your questions. Thank you very much.